Hello dear learners, I am Dr. Nishant Yadav and welcome to lecture number 16 of the course on Essentials of Surveying Applications and Techniques. In this class, we will discuss how to measure angles, both horizontal and vertical, using theodolite. By now, hope you all are familiar with the various components of theodolite. Theodolite, which is an optical survey instrument which is known for its accuracy and precision. And we all have realized that because of its versatility, speed and accuracy of the survey instrument theodolite, it is more preferred over the other conventional survey instruments. When we say a versatile instrument, theodolite is used in all kinds of engineering survey work. It can be used in triangulation, traversing and tachometric surveying. We talked about the various applications of theodolite in field surveying, like to measure horizontal and vertical angles precisely, for alignment of roads, railways, bridges, etc., for prolonging survey lines or extending the survey lines, for setting out or to find the grade of the slope or to measure the slope, or for laying out curves, for measuring deflection between 2 points. So, all this work can be done by a single instrument, theodolite. A surveyor should know about the 5 fundamental lines or axes in a theodolite and their relationship with each other. If you are familiar to the components of theodolite, you can very well understand the relationship between fundamental lines and axes, namely the vertical axis, the horizontal axis, the line of sight which is parallel to horizontal axis and perpendicular to vertical axis, the bubble axis or the altitude level axis or the plate level axis. In this lecture, we will learn how to measure or record the angles using theodolite, but before that, the surveyor should not forget the 2 adjustments of the theodolite that has to be done: permanent adjustment and the temporary adjustment. The permanent adjustments are made to establish the relation between the fundamental lines of the theodolite, and once done, they last for a long time. Permanent adjustments are essential for the accuracy of observation, and they are done by trained technicians only. Temporary adjustments are to be done at every station where the instrument is set up. Without these adjustments, the instrument is not ready to take survey readings. The temporary adjustments in theodolite survey includes the following 3 operations: centering, leveling and focusing of eyepiece as well as objective. In order to use theodolite, it is also important to understand the mechanism how the theodolite works. For this, it is essential to know the components of theodolite. If you can recall that the base of theodolite consists of 2 plates, the upper plate and the lower plate, and these plates are attached to 2 spindles. The inner spindle is solid and conical, whereas the outer spindle is hollow, and within the outer spindle, inner spindle is attached. The arrangement of the 2 spindle is something like this: the inner spindle, and over this the outer spindle is mounted, such that the 2 spindles can rotate about the vertical axis. Outer spindle is hollow and the inner spindle is solid, but they are aligned at the same vertical axis. Remember that the inner spindle is connected with the upper plate, whereas the outer spindle is connected to the lower plate. So, try to visualize this is a spindle and over this plates are connected. Again I will tell that the inner spindle is connected to the upper plate which carries the vernier scale reading, and the outer spindle is connected to the lower plate which carries the main scale reading, and it is graduated readings of 0 to 360 degree in clockwise direction with the smallest divisions of 20 seconds. The plate, that is the lower plate and the upper plate, are so equipped that they can be clamped. Clamped in a sense, you can restrict their movement as per the choice of the surveyor. We can look at these plates in the components of the theodolite. You can lock the lower plate or the upper plate. You can release both the plates, or you can lock one plate and release the other plate. It totally depends upon the choice of surveyor. Another feature of these clamping screw is their corresponding slow motion screw or tangent screw. What is the function of slow motion or tangent screw? Once you have locked the plate, and for accurate bisection, or you want to sight any object precisely, you need to move the telescope or the readings, then you can use this slow motion screw or the tangent screw. The locked plates can only be rotated slightly for precise adjustment or precise reading with the help of these tangent or slow motion screws. Now, things will get more clear. To measure the horizontal angle, we use lower plate, also called as horizontal circle. Horizontal angle measured by using horizontal circle. Make sense? Right. Horizontal circle carries main plate and it is mounted on a hollow tapered spindle, as it is called as the outer spindle. The size of theodolite is determined by the diameter of this horizontal circle. It ranges from 10 centimeters to 13 centimeters. Suppose you go to an office and your boss asks you to bring the theodolite. So, you can ask what type of theodolite. So, the answer would depend upon the diameter of the horizontal circle. It ranges from 10 centimeter to 13 centimeter. So, to be precise, knowledge of all the items should be essential. The surveyor can unclamp the both screws. This is done to set the instrument reading to 0 for the reference survey line. On clamping the upper clamp and unclamping the lower clamp, the instrument can rotate on its outer spindle without the relative motion between the two plates. So, try to visualize. There are upper plate, lower plate. You have the facility to clamp the upper plate or the lower plate, or you can clamp both the plates. So, suppose you do not want any relative motion between these two plates. So, what you need to do is clamp the upper and unclamp the lower plate. On the other hand, if the lower clamp screw is tightened, that is, you have clamped the lower plate and the upper clamp screw is unclamped, or you have released the upper plate, the instrument now also can rotate, but it will rotate about the inner spindle. A relative motion between the two plates will take place, and this property we are using at the time of measuring angle. Suppose you do not want relative motion between the two plates, what you do? Clamp the upper plate, and if you want to measure angle, you need to rotate, you need to change the angle, you need to change the graduation. In that case, what we can do? We will unclamp, or we will tight the lower plate and unclamp the upper plate. Let us see how to measure horizontal angle using theodolite. Suppose we are at any station Q and we want to measure the horizontal angle theta, that is angle P, Q and R. So, the step 1 would be to set up the theodolite at the station Q with vertical circle to the left of the line of sight, that is face left, and complete all the temporary adjustment like centering, leveling and focusing. Remember, we have to take readings from face left and face right. Face left, in a sense, the vertical circle is to the left of the line of sight, or to the left of the observer, or to the left of the telescope. This setup is called face left. And suppose this vernier scale is on the vernier circle is on the right hand side of the observer or the line of sight, it is called as face right. Now, at this moment we will release both the plates, that is upper plate and the lower plate, and we will gently turn the theodolite or the setup to get 0 degree on the main scale. Once we get 0 degree on the main scale, at this point what we will do, clamp the main screw, and using tangent screw exact reading 0 reading is obtained. At this stage, when you have set the instrument exactly at 0 reading, the vernier A reading should be 0 and complementary to it the vernier B reading should be 180 degree, and it should be very exactly or precisely done. Then place a ranging rod at point P. Remember, we need to measure angle between P, Q and then place a ranging rod at point P. Remember, we are measuring angle PQR. So, one ranging rod is placed at P, and through the telescope take the line of sight to signal at point P. And at this point, when you have sighted point B, lock the lower clamp. Use of tangent screw can be done for exact bisection, means the crosshair and the ranging rod should coincide. And remember, when the lower clamp is screwed or it is tied or locked and the upper clamp is released, the instrument will rotate about its inner spindle and the relative motion between the plates will take place. So, release the upper clamp and swing the telescope to bisect the ranging rod that is placed at point R. So, we are swinging the telescope, now we are bisecting the other point that is at R, and at this point lock the upper clamp and use tangent screw or the slow motion screw for the exact bisection of the signal at point R. So, read the vernier reading at A and B, both readings are to be taken. The reading of vernier A, which earlier was set to 0, will give you the desired angle PQR directly, whereas 180 degree is to be subtracted from the reading of vernier B to get the value of angle PQR. Now, what we will do? We will transit the theodolite. Transit means to rotate the telescope by 180 degree in vertical plane about the turn-on axis or the horizontal axis, so that the vertical circle is to the right of the telescope. This position is called face right position, and repeat the steps 2 to 5 to get more values of angles. Just a quick recap of the procedure: clamp the upper plate and lower clamp can be loosened to sight the point B. When any plate is locked, what you can do to move them slightly, use the corresponding tangent screw, and while noting the reading, it is a good practice to clamp both the plates. The lower plate is clamped and the other plate, that is the upper plate, is loosened to swing the telescope from point P to point R. Vernier A gives direct reading, while reading of vernier B is to be subtracted from 180 degree. This method of measuring angle is known as the general method or the ordinary method of measuring horizontal angle. Whereas, we are doing high level precision work or the nature of survey work needs accuracy as a priority work. At that time, we are adopting one of the two scientific methods for measuring horizontal angle. The first one is a repetition method, the second one is retration method. In repetition method, it is adopted when we are doing accurate work. As the name suggests, the same angle is measured repeatedly. In this method, the same angle is added several times mechanically, and we measure the angle AOB. Suppose we are at any station O and we are interested in measuring angle AOB between two survey lines OA and OB. We get the measure of the angle, say suppose 30 degree. So, what we do? We lock the plate again such that the initial reading, which was 0 earlier, is now 30 degree. So, the next trial, the initial reading will be 30 degree, and then side OB, now the reading would be 60, and the next time when we do the same procedure, it will be 90 degree. So, what we get? We are continuously getting a cumulative value. The initial reading in the first cycle would be 0, next cycle it will be 30 degree, third cycle it will be 90 degree. And the final correct value of the angle is obtained by taking the average of the values by dividing the accumulated or the cumulative reading by number of repetition. Generally, we are taking 3 repetitions. The number of repetition usually depends upon the discrete of surveyor or the extent of work that we are doing. It is, as I said, it is 6, 3 with face left and 3 with face right. In this way, the angle can be measured to a finer degree of accuracy that obtainable with the least count of the verniers. Just a quick recap, again and again I am trying to tell, just because the lower clamp, lower plate, upper plate, it seems quite complicated, but with practical exposure you will be able to understand it in better way. On clamping the upper plate and unclamping the lower plate, that is, upper plate is locked and lower plate is released. The instrument can be rotated and it will rotate about the outer spindle without any relative motion between the plates. That means, there will be no change in reading even if we rotate the theodolite by 360 degree, there will be no relative motion, the readings will be locked. If you rotate the theodolite by 360 degree, because only the outer spindle is rotating, remember that this operation we will require when we are doing the repeating process. So, let us take a case of measurement of horizontal angle between points P, O and Q by repetition method. Theodolite is positioned at a point O and one ranging rod is kept at placed at point P and the other ranging rod is placed at point Q. Now, set up the theodolite at the starting point O, and when we say set up the theodolite, it means all the temporary adjustments are to be done and leveling has to be done accurately. Set the vertical circle to the left of the observer, because generally we start the process with face left reading. Both the screws are released and loosened. Now, both the plates are free. Now, what we do? We will sight point P, that is the first point. At this point, we will set the vernier A reading to 0 and automatically the corresponding vernier B reading would be 180 degree. Now, we want relative displacement between the plates for measuring angle POQ. So, we have set P point as reading as 0. Now, we will swing our telescope to the point Q. At this point, we are interested that there should be relative displacement between the two plates. So, what we do for that? The upper plate is loosened so that the inner spindle will rotate and lower clamp is tightened. Is it clear? The upper plate can now rotate over the lower plate, then we will sight point Q and record the reading. The angle is measured directly in vernier A reading, and as I told, vernier B reading would be 180 degree greater than the actual value. So, the key word is, when you want relative displacement between the plates, we have to loosen the upper clamp. Okay, moving ahead, when we lose the lower clamp and turn the telescope back to point B, at this point the reading is not 0. What we have done? We have loosened the lower clamp and turn the telescope back to point P. Remind you that this is a repetition method. In this, we are repeating the same values 3 times with face left and 3 times with face right. Now, when we come back to point P again, we will find that the reading is not 0, it is actually equal to the angle measured in the first cycle. For this to happen, the upper plate is clamped and the lower plate is released. There will not be any relative motion between the two plates. So, when you do not want any relative motion between the two plates, upper plate is to be clamped and lower plate is to be released. Now, bisect point Q again as accurately as possible with the help of tangent screws, because once these plates are locked, it can be very gently or minutely adjusted by using this tangent screws. At this point, the reading in the vernier will read approximately twice the initial value. Repeat the process usually 3 times. Record both vernier A and vernier B readings. The final reading would be average of the all values, and we will divide the cumulative sum of number of repetition by the number of cycles or number of times the angle is measured. By this, we get a correct value of angle POQ. Once this is done, the next in continuation, the face of the instrument is changed. That is, 3 readings are recorded, will be now recorded from face right, which means the position of vertical circle with respect to line of sight has to be changed. Now, repeat the same procedure with face change. Generally, we start the process with face left, and in the second half we take the readings with face right and find other set of values for angle POQ. The average of all the readings will give the required precise value of angle POQ. The other method of measurement of horizontal angle is retrition method. This is also called direction method or closing of horizon method. It is basically adopted generally in closed traverse or at a place where multiple number of readings around the theodolite are to be taken. This method is another precise and comparatively less tedious method for measurement of horizontal angle using telescope or theodolite. It is generally preferred when several angles are to be measured from a particular station. This method consists in measuring several angles successively and finally closing the horizon at the starting point. As we can understand, the final reading of vernier A should be its initial reading. If it is not, that means there is some discrepancy, and this discrepancy is distributed equally amongst all the measured angle. Remember, we are forming angle simultaneously, we are measuring several angles in a circle. So, whatever is the first reading has to be the last reading also, and if there is a mismatch, the amount of discrepancy has to be distributed amongst all the measured angles, or if the discrepancy magnitude of discrepancy is high, we need to discard the reading and we need to remeasure all the angles. Let us consider a case for measurement of horizontal angle using retrition method. Suppose the theodolite is at point O, and around the point O there are 4 points P, Q, R, S, and it is required to measure the angle POQ, QOR, S, ROS and SOP, such that the sum of all the angles should be 360 degree. If the value sum of all the angles is not 360 degree, suppose it is more than 360 degree, the error is +1, then we need to distribute this 1 degree to all the angles measured. Or suppose the angle, final angle, or the sum of all the angles is less than 360. Suppose it is 359. So, 1 degree less has to be added. So, likewise, if the error is positive, the correction would be negative and vice versa. Now, we will see again. Lower plate is locked, no relative motion between the plates, entire theodolite will rotate without changing the reading. So, suppose you want to lock a reading and rotate the theodolite. For this, lower plate has to be locked, and for measuring any reading you need to release the upper plate, so that reading will change. For measuring angle, loosen the upper clamp screw and the lower clamp is tightened throughout the process. We are talking about the retrition method, in which we are cumulative values of angle we are measuring. For measuring angles, we need to lose the upper clamp, right, and for keeping the value 0 value to a specific point, we will lock the lower clamp. We will come to it again. Whenever we want to rotate the telescope to measure reading, upper clamp screw is released. So, whenever we want to measure any angle from P, we want to rotate the telescope to next point, that is Q, and we want the readings to change. So, what we do, upper clamp is released, and throughout the entire process the lower clamp would be clamped. The instrument is rotated about its inner spindle. A relative motion between the plates will take place. So, we will see the process. Set up the instrument over the station point, say O, and all the temporary adjustments, leveling, focusing, centering is done accurately. Now, direct the telescope to the first point, say in our case it is P, and this will be regarded as the referring object. In this case, the particular case, point P, which is the first point, will be regarded as the reference case. Bisect it accurately and check vernier A reading as 0 and vernier B reading should be 180 degree at this time. In the entire process, once the first point is sighted and 0 reading is achieved, set the horizontal circle, that is lower plate, which carries main scale reading, to locked position. In the entire process, the lower plate will be locked, and loosen the clamp and turn the theodolite clockwise. Whenever we are taking face left reading, it is common practice that we go clockwise. Suppose the next point is Q. In our case, we will bisect it very accurately, clamp the plate, and accurate bisection is done by slow motion or tangent screw. Read the vernier reading again. The mean reading will give you the value of angle POQ. You will measure angles from both vernier A reading as well as vernier B reading. Vernier A reading will give you the direct value of the angle, whereas vernier B value will be 180 degree more, as it is initial value was 180 degree, right. Similarly, we will continue the similar process and we will bisect point R and S successively. Read both vernier readings at each bisection, find the value of angle QOR and angle ROS and note the readings. Finally, close the horizon by sighting towards the referring object. When we started our measurement, we took point P as the reference point. So, again we will measure the same point P. So, if we are forming a closed circle, the reading should be 360 degree. So, at this point the vernier A reading should be 360 degree. If the vernier reading is not 360 degree, the amount of variation is the error that is there in the reading, and errors in the reading can be because of numerous factors that we will discuss in later section. If the error is small, it is equally distributed amongst all the angles. and if the error is large, the reading should be discarded and new set of readings has to be taken. With theodolite, we can measure vertical angles also. A vertical angle is an angle between inclined line of sight and the horizontal. Remember, we have the provision of inclining the line of sight with the telescope that can be rotated about its horizontal axis. So, the angle between the line of sight which is inclined and horizontal is called as the vertical angle. It can be positive, it can be negative, because if the angle object is above the line of sight, it will be referred to as the angle of elevation, and suppose if the point is below the line of sight, it will be termed as angle of depression. That depends whether the object is above or below the horizontal plane. Suppose we have to measure vertical angle of point P and instrument is set up at point O. Set the instrument at station O and level it accurately with the reference altitude bubble. Set the 0 of the vernier scale that is present in the vertical circle. We are interested in finding the vertical angle. So, this time we will use vertical circle that is adjacent to the theodolite or the telescope. The vernier scale reading should be 0 at the moment and vertical circle will be clamped, and whatever movement is required will be done with the help of tangent screw. Bring the bubble of the altitude level in the center position by using the clip screw. Now, we have another screw, that is clip screw, which helps to bring the bubble to the center of the run. The line of sight is thus made horizontal and the vertical or the vernier reading will be 0. Loosen the vertical circle clamp screw and direct the telescope towards the object P and sight it exactly by using the vertical circle. Slight movement can be done by tangent screws. Read both the readings, vernier readings on the vernier scale. It means that 2 vernier reading will give you the value of required angle. Change the face of instrument and repeat the process. The mean of the 2 vernier readings will give the average value of the required angle. Now, suppose we want to measure 2 vertical angles between 2 points A and B. So, we are standing at point O, there are 2 points, there is one point A and there is another point that is B, and we are setting at point O. So, what we do? Sight A as before, as done in the previous example, and take the mean of the 2 vernier readings at the vertical circle and let this angle be marked as alpha. Similarly, sight point B and take the mean of the 2 vernier readings and mark this angle to be beta. The sum or the difference of these angles will give you the value of vertical angles. As you can see in the figure, in some case angle alpha plus beta will give you the value of AOB, whereas in some cases alpha minus beta will give you the value of AOB. It depends upon the position of the object A and B, according as one of the position is above or below the horizontal plane, or both points are on the same side of the horizontal plane. That is it for today. We will take up next topic, that is prolonging survey lines, in the next class. Thank you.